So in section 4.2, we're going to be talking about graphs of exponential functions. So we're going to start with two exponential functions that we have here. F of x equals 2 to the x, and then h of x equals 3 to the x. First, let's graph f of x. So I'm going to make a little table of values here. And I'm going to put in some numbers like -1. Well, let's put in -2. -2, -1, 0, 1, and 2. Now we're plugging them into this function. Now remember, when you put 2 to the power of -2, that's going to reciprocate, so it's going to be 1 over 2 squared, which is going to be 1/4. And then when you do -1, you're going to get 1/2. Remember that 2 to the 0 is 1, and then 2 to the first power would be 2, and 2 squared would be 4. So we're going to get this, my piece of graph paper is a little small, but we'll graph it anyway. -2 1/4, and then -1 1/2, and then 0 1, 1 2, and 2 4. And so we get this curve. Oh, I lost 2 4. Okay, we get this curve like this. Remember, it's going to run asymptotic to the x-axis. So there is an asymptote right here on the x-axis. Okay, and so we have that graph looking like that. Okay, let's look at h of x now. H of x, we're going to have x, h of x. And we're going to do a similar thing. We're going to just plug in -2, -1, 0, 1, and 2. And we're going to get 1/9, 1/3, 1, 3, and 9. And now we're going to graph it right on this same graph. So -1/9, it's going to be under, it's going to be hard for me to show this. It's under the black graph. See if I can get it in there. 1/9, see, is less than 1/4. And then I'm going to have 1/3. 1/3 is less than 1/2. But then at 0, 1, notice that they both go through the point 0, 1. And now it's going to be 1/3. Sorry for this graphing problem. I really wish it weren't doing this. And then I have 2, 9, so way up here. So what happens is I get this curve like this. Okay, let me draw it better. So you have a curve that's like, well, it's going up a little quicker than that. Let me erase it. A curve that's going like this, call this f of x, but then when it's h of x, it has a point that they have in common, that point 0, 1. It's underneath, and then it's going up quicker, not linear, but more like a curve. And so it kind of crosses over. That's what's going on with those graphs. Now, what does it mean? It means that the base here, that is 2, and the base here that's 3, that makes a difference. If you had 5 to the x, that would be a different curve, okay? So these functions, remember, an exponential function is based on f of x equals a b to the x. I think that's what we had for our general form. It makes a difference what b is, okay? So they refer to this as what's called the parent function. When that base is a base that's going to be consistent, and then you're going to make some transformations to it, that's what they're talking about, but they're going to use that term. I'll try to go over it again. Okay, so in this case, the horizontal asymptote was y equals 0 for both of those functions. The domain was -∞ to infinity for both of those functions. The range was, now it's going to be 0 to infinity. We don't have any points below the x-axis, right? Okay, so the range, it doesn't Include 0 because we're not actually touching the x-axis. The x-intercept, there are none for both of those graphs. And then I have to scroll up a little bit. And the y-intercept was 0, 1. It was an increasing graph. Okay, so all this information that I just put in orange all had to do with this graph right there. Okay, now we're going to do another graph. So we have a base of 1/2. So it's like a new parent function here. And don't get too concerned about that phrase parent function. You'll see it later in this section how we're going to use it. Okay, so if I do a table of values, x, g of x, and I put in, let's say, -1, 0, 1, and 2, what happens when we take 1/2 to the power of -1, it's going to reciprocate. So you're going to get 2, and then 0 will get you 1, 1 will get you 1/2, and 2 will get you 1/4. I guess I could put in -2. -2 gets you 4. All right. So now let's graph this. -2, 4, right there. -1, 2. Then it's going through 0, 1. That point was in common. And then it's getting closer to the x-axis now. So it's this curve like that. Like that. Okay. Now let's go back and look at the description here. What's the horizontal asymptote? Y equals 0. What's the domain? -infinity to infinity. The range, still 0 to infinity. The x-intercept, there are none. The y-intercept, it does go through the point 0, 1, but this time it is a decreasing curve. Okay, so you notice this time it's going, compared to this other one in the orange box, it's going in a different direction. It's going down this way toward the x-axis, and so that's decreasing. I want to point out one more thing. Notice that if you take this function and write it as 2 to the -1 for 1/2, right? 2 to the -1, that would be the same thing as 1/2. And then you use rules of exponents, you get that function to be 2 to the -x. Now, if you think back to transformations, what happens if you put a negative in front of x before you apply the function? It makes it reflect about the y-axis. Not the x-axis, okay, but the y-axis. So if you look at the 2 to the x, f of x was 2 to the x up here, that's what's happening. This one is reflecting about the y-axis, okay? We're going to talk more about that when we talk about reflections, but I just wanted to point that out there.